If you've spent any time online, and I mean any time at all, you've probably seen the meme
Oh, another one.
that eventually everything evolves into a crab. It's funny, but the weird thing is nature really does seem to have an obsession with this particular shape.
It's absolutely true. The phenomenon is called carcinization, and it's this remarkable example of convergent evolution.
Convergent evolution.
Yeah. A biologist named Lancelot Alexander Borodale actually called it, way back in 1916, the many attempts of nature to evolve a crab.
That's amazing. So that's our mission for this deep dive, to figure out why this body plan is so successful that it's appeared at least 5 separate times in crustaceans that weren't crabs to begin with.
Exactly. Carcinization is basically the process of going from a long, sort of vulnerable body like a lobster or a shrimp
Right.
to that classic, compact, crab-like form. It's a huge physical change. It involves taking the long abdomen, which we call the pleon, and folding it really tightly into the main body.
The cephalothorax.
The cephalothorax, yes.
Yeah. And this is where it gets a little tricky, right? Because not everything that we call a crab is technically a true crab.
We have imposters. Successful ones, but imposters. You have the true crabs, the Inforter brachyura, then you have the lookalikes in the Inforter and Anomura.
So how can you tell them apart?
The easiest way, honestly, is to count the legs. A true crab has 4 pairs of walking legs you can clearly see.
Okay.
But the carcinized ones, like a porcelain crab, they've got 1 pair that's much, much smaller, so they really only walk on 3 pairs.
Huh. And that brings us to the king crab. They look like the definition of a crab. Huge, armored.
They do.
Yeah.
But the sources are pretty clear that most scientists believe they evolved from, get this, asymmetrical hermit crab ancestors.
Hermit crabs. But they don't have shells.
Exactly. But the proof is still there. If you look inside a king crab's carapace, its abdomen, the part tucked away, is still asymmetrical. It's a leftover signature from its shell-dwelling past.
That is incredible. So what's the big advantage? What's the evolutionary pressure that makes this shape so optimal?
It really boils down to 3 things: stability, protection, and maneuverability.
Okay, let's break that down. Stability.
That wide, flat body gives them a super low center of gravity. It's perfect for that evasive, sideways walking they do, especially on the rocky ocean floor.
And the protection part seems obvious. They're like little tanks.
They are. Tucking that soft abdomen underneath minimizes weak spots. And for a creature like the giant coconut crab, that compact body is a huge benefit for moving around on land.
But there's always a trade-off in evolution. What do they lose?
They lose the classic lobster escape move.
The tail flip.
The charadoid escape reaction, yeah, that powerful backward flick. A crab's tail is so strongly bent and immobile that those muscles just aren't there. They have to rely on scuttling and hiding instead.
You know, uncovering these kinds of optimized, repeatable patterns, this one design that nature just keeps returning to, it's just fascinating.
It really is. It shows that when the constraints of a problem are clear, the most efficient solution is often, well, it's almost inevitable. Finding those pathways is how progress is made.
And you know, speaking of finding optimized solutions, this deep dive is sponsored by Embersilk. If your business needs help with AI training, automation, or software development, Embersilk helps you uncover where AI can make the biggest impact.
Finding the most efficient pathways.
Exactly, just like nature did with carcinization. Check them out at embersilk.com for your AI needs.
And, you know, to bring it back to the bigger picture, evolution is always experimenting. The sources note that while carcinization is this super successful path, the reverse also happens.
It's a reverse.
Yeah, decarcinization, the loss of the crab-like body. It shows evolution is constantly testing and re-optimizing. It's never static.
And sometimes it pushes the design even further. What's this hyper-carcinization?
That's the extreme case. A porcelain crab called Allopetrolist's spinifrons develops sexual dimorphism. The males have a shorter abdomen than the females, just like true crabs do. It's refining the design even further.
So the meme isn't quite right. It's not that everything is becoming a crab. It's specific to these marine decapods. But the deeper idea is, well, it's kind of profound.
It is.
That facing the same physical challenges, nature independently discovered this exact, highly optimized solution for armor and mobility over and over again. It's such a powerful illustration that an optimal design is out there, and it can be found.
It's a hopeful thought, really, that constraints can breed genius, and the best solutions often reappear, no matter the context.
If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.